All right, so here's your homework, solving trig equations. And some of these might involve identities I haven't gone through with you, and that's okay. When it involves something of what we haven't gone through, we're just going to skip it and do the questions we will do together. So to solve this, step one is to get cosine, in this case cosecant by itself. So to do that, I'm going to divide by 9. Now, when I do that, I'm also going to reduce it down. So I'm going to divide top and bottom by 3. And then I'd rather work with sine than cosecant, so I'm just going to do the reciprocal. And understand the reciprocal of that is root 3 over 2. Now, I need to know the rule for sine. So sine is the y-coordinate. So I know the y-coordinate is root 3 over 2, and that means the x-coordinate must be 1/2. I'm looking for an angle. I need to know what quadrants we're in. So I can tell that it's positive. So all students take calculus. So I know that's quadrants 1 and 2. Now, I want to know all answers from negative infinity to infinity. So what I have to do is I have to set up and understand this, that in quadrant number 1, the answer would be 60 degrees, or pi over 3. But it could be periodic, so every time, right, over and over and over again. So that means to this angle, I got to be able to understand that it's that angle plus every rotation of 2 pi. And you can use k or you can use n. So in the answer key, uses n, so that's fine. The other answer possibility, that means if I want to find the answers, you just plug in different numbers for n, different integers. So I could plug in 0, 1, 2, 3, 4, and that would always be the correct answer. That would give you that answer. In quadrant number 2, the angle is 2 pi over 3. And again, I'd have to do the same thing to find all the answers possible. All right, number 2, can you get sine by itself? So step 1 is to subtract root 3 over 4. Now, to do that, I need common denominator, so I'm going to multiply by 2, top and bottom. So that's 6 take away root 3. I'm just hesitating. Oh, I know what I did wrong. So I wasn't like, it was all kind of squished in there. I have to combine like terms. So I want to bring those together. So I'm going to subtract 3 over 2 to the other side. So the sine thetas can be together. So when I subtract and I go 2 take away 1.5, that's where you get the 1/2 from, when you subtract. So to bring them together, I'm going to subtract, and then I'm going to subtract root 3 over 4 to isolate the sine theta, and then I'm going to multiply both sides by 2. And when you do that, you get negative 3 root 3 over 2 when you multiply by 2. Again, I need to understand the reference angle of this. So that's the y-coordinate. So the x-coordinate could be positive or negative 1/2 to go with it. So the quadrant that we're in when sine is negative is here in the bottom part. Quadrants 3 and 4, it's negative. So what are those angles? What's the reference angle? So the reference angle is pi over 6. So one answer down there for over 6 would be 7 pi over 6, and then the generic solution. And the other one would be 11 pi over 6, and then the generic solution, where you'd plug in 1, 2, 3, 4, whatever, to find whatever answer you want to find. what is it? Oh, 60 degree. So this should be 4 pi over 3, and this should be 5 pi over 3. Dear me. Okay, number 3, moving on. Hey, I love that cute little fish. That's alpha. So we're going to multiply everything times 2 to begin with. Then we're going to combine like terms. So I'm going to subtract 2 to the right side. So 4 subtract 2 is 2 cosine alpha. And I'm going to subtract 3, and 2 subtract 3 is negative 1. Then divide, and I get cosine alpha is negative a half. So understand that that's my x-coordinate. The y-coordinate could be positive or negative root 3 over 2. What quadrant is that in? So for cosine to be negative, it's going to be in quadrants 2 or 3. So in quadrant, and what's the reference angle for this? So again, it's 60 degrees. So in quadrant 2, that would be 2 pi over 3. And the generic answer would involve 2 pi. Or down here in quadrant 3 would be 4 pi over 3. And again, the generic answer to that. All right, number 4. Step 1 is to combine like terms. So I'm going to add 6 to negative 3. That's positive 3. Subtract 3 on the other side. Just do the algebra to get cotangent by itself. And you get negative 1. Understand the rule is x divided by y. And so if I'm getting the answer 1, it must be root 2 over 2 and root 2 over 2. It must be a 45-degree angle. So in which quadrants is cotangent negative? So that's 2 and 4. So that means the answer here must be 3 pi over 4, and then the generic part to it. Or in quadrant 4 must be 7 pi over 4 plus the generic part to it. All right, number 5. Now we have a restriction where we don't need that generic part to it. So I want to get tangent by itself. So I'm going to add 7. That's 15. I'm going to divide by 5, and that gives me 3. And then to undo the square, I need to square root. And the answer could be positive or negative. So the rule for tangent is y divided by x. So what point on the unit circle when I go y divided by x gives me that answer? So that's root 3 over 2 and 1/2. So that means the reference angle is 60. So I need to understand that all, so where is it negative and where is it positive? So that's everywhere. But between pi over 2 and 3 pi over 2, the only two quadrants I want my answer in is quadrants 2 and 3. So the answer could be positive or negative. That's why it's all the quadrants. But my restriction says, nope, just quadrants 2 and 3. So 60-degree reference angle is over 3. So that's 2 pi over 3 and 4 pi over 3. Number 6. To get secant, oh, I love beta. So there's beta. To get it by itself, multiply by 4, then subtract 10. Now, I'm going to do the reciprocal to make life a little easier. So that means cosine then must equal 1/2. And then think of my quadrants. So cosine is positive in quadrants 1 and 4. But with this restriction, I'm only going to focus in on quadrant 4. Because quadrant 1 is not in my restriction. So only in quadrant 4 am I going to get my answer. So my x-coordinate is 1/2. The y must be root 3 over 2. And it's going to be a negative there. But what's the reference angle there that will get me there? So the reference angle for this is 60. So that's over 3. And then what's the angle there that will get me there? And the answer is 5 pi over 3 when you count around. Number 7. So I'm going to do some factoring here. So I'm going to factor out a cosecant theta and be left with root 3 plus cotangent theta equals 0. So there's two options here. One could be cosecant theta could equal 0, or root 3 plus cotangent theta could equal 0. So for the first example, where is cosecant theta equals 0? And I need to know my rule here. So the rule here is cosecant, the reciprocal. Well, I can't even do the reciprocal of 0 to figure out sine. There is nothing that will give me the answer 0 here. So for this one, there's no solution here. For this one. So this gives me no solution. But this one might give me a solution. So subtract root 3. It's x over y. That's the rule. So that's root 3 over 2 and 1/2. X over y gives me that answer. What quadrant are we in? So for cotangent, that's negative. It's 2 or 4. And for this restriction, it can only be in quadrant number 2. So what's the angle in quadrant number 2? So it's a 30-degree reference angle. So the angle in quadrant number 2 is 5 pi over 6. Number 8, factor it. So factor out a tangent x. And then make that equal to 0. Can tangent equal 0? Yes, so that's okay. Cosecant squared, 0. So if I solve this for cosine, it could be positive or negative 1. And so again, understand what quadrants we're in. So we're only from 0 to pi in quadrant number 1 and quadrant number 2 only. So tangent is 0 at 0. So one answer is 0, and that's included because of the bracket. And it's also equal to 0 at pi. For cosine, cosine is positive 1 over here on the right, and is negative 1 over here on the left. So again, I get 0 and pi for my answers. And that's it. Those are the two angles that give me the answer that solve this equation. So again, I'm going to factor here. There it is. So in order to factor, I need to make it equal to 0. And I'm going to rearrange it. So I want the squared term to be positive. So I'm going to add it to the left side. I'm going to add 4 secant y to the left side. And I'm going to add 5. That way everything's positive, and then I can factor it. So think of this the same as you would think of x squared plus 4x plus 4. Same idea. So how would you factor this? It would just be x plus 2, or x plus 2 squared. Same thing here, it's just that you don't have an x. So in this sense, you would have secant y plus 2, and it would be squared instead. So you only have one answer here. So it's when secant y is equal to negative 2. To do the reciprocal, that's negative 1/2. And again, understand the quadrant that we're in for this. So if I think it's between pi over 2 and 3 pi over 2, it's in quadrant 2 or 3. Now, cosine's negative in both of them. So both will be that. What's the reference angle for this? So if the x coordinate's 1/2, it's 60 degrees. So both of these answers are going to have a 3. So I have 2 pi over 3 and 4 pi over 3. All right, combine like terms here. So I'm going to add 2 to the other side, so it's positive 1. Then take the square root, and the answer could be positive or negative. Know my rule. It's x divided by y. Know my quadrants. So 0 to pi is just here. So what's the reference angle when cotangent's root 3? And the answer is 30 degrees. That would be root 3 over 2. and 1/2. That's what will give me that answer. So in quadrants 1 and quadrant 2, you get the answer pi over 6 and 5 pi over 6. All right, number 11, can you factor it? So combine like terms. So I'm going to make it equal to 0. I'm going to add, so it'll be plus 2 cosine squared beta. And then I'm going to factor out. So I'm going to factor out a cosine and be left with root 3 plus 2 cosine. And then those are my two possible answers. So cosine beta could equal 0. So what angle is the x-coordinate 0? So the answer is, and within this domain restriction, it's all 4 quadrants. So that's at pi over 2, and the other possibility is 3 pi over 2. For the second part, we're going to make this equal to 0. So to get cosine beta by itself, we're going to subtract root 3 and divide by 2. So what's the reference angle there? That could also be it. So where is cosine negative? So understand it's negative in quadrants 2 and 3. What's the reference angle when the x is root 3 over 2? So it's a 30 degree. And then in quadrant 2 and in quadrant 3. And then you get all 4 answers that satisfy the domain restriction. Number 12, get cosecant squared by itself. So we're going to subtract 7. So 19 subtract 7 is 18, and then divide by 9. Then you're going to do the square root. Now, the answer is positive or negative. If you want to, you can do the reciprocal here. And then when you rationalize it, you would see better what the reference angle is. So this reference angle is 45 degrees. Be aware of the quadrant here. We're just talking about 2, 3, and 4, just these quadrants, right? From pi over 2 to 2 pi. So I know the answer is over 4. I know there's 3 angles, but I'm not including quadrant number 1. So it's 3 pi over 4, 5 pi over 4, and 7 pi over 4. What did I do wrong here? Ow. I did it again. So 19 take away 7 is 12. And 12 divided by 9, geez Louise, is 4/3. And when you take this, it is 2 over root 3. And then when you do the reciprocal, is actually root 3 over 2. And then where's the y-coordinate root 3 over 2, right? So it's 60 degrees, so it's over 3. Over 3. And then it would be 2 pi over 3, 4 pi over 3, and 5 pi over 3. Number 13. I want to solve this. So I'm going to combine like terms. Let's see if I can do it right here. Subtract 1, that's 2 cosine squared y. I'm going to subtract cosine y, and we still have a subtract 1. Let me show you an algebra technique here that would be helpful. Let x equal cosine y. That means this is 2x squared minus x minus 1. So I don't have to worry about trigonometry here. 2 times negative 1 is negative 2. So to factor this, the two numbers I'm going to use are negative 2 and 1. I'm going to do a substitution. Then I'm going to factor by grouping. And then I have my two factors. So one factor, let's just say 2x in front, x minus 1. All right, so 2x plus 1 and x minus 1 are my factors. So once I know that, now I can plug in for x, I can go cosine y. So it's 2 cosine y plus 1, make that equal to 0. And then the other one is cosine y minus 1 equals 0. So we're going to solve each one by getting cosine y by itself. So 1 could be 1. Here, subtract 1 and divide by 2. So it's just quadrants 3 and 4. So I'm looking for the x coordinate and for the answers that would work. So 60-degree reference angle. So this would be 4 pi over 3. And that's it. And then, because the one in quadrant 4 cosine would be positive, where's the x coordinate? Positive 1. And that answer would be at 2 pi. So it's just 4 pi over 3 and 2 pi. Number 14. Again, you could use this technique. Make it equal to x, and then you're just factoring just normal algebra. So 2 times 3, what two numbers am I going to use? So then once it's factored, so just basic algebra. Then when you actually write it, then plug the trig back in. So x is sine A plus 3 equals 0. So could sine A equal negative 3? No, that's not possible. So there's no solution there. Then the second one, plug in sine A. So to get sine A by itself, you subtract 1 and divide by 2. Where's the y coordinate 1/2? What's the reference angle? So that's 30 degrees. We're only in quadrant number 4. That's what that is, or quadrant number 3, I mean. So in quadrant number 3, it would be 7 pi over 6. Factoring again. So again, combine like terms. Even at the beginning, if you make it equal y then, and then have 7y squared plus 11y minus 1 equals 1 plus y squared. If you can just make it algebra, combine like terms. So subtract y squared, subtract 1, and then factor it. So that's negative 12 and 11. So that's negative 1 and positive 12. And then factor out a y. Factor out a 2. So one answer would be y plus 2. We're going to plug in secant. And the other one would be what did I do? So for this one, when you add that, there's no solution here. Because secant has to be bigger than 1 or smaller than negative 1. For here, you have a solution. So secant negative 2 is the same as cosine and the reciprocal. The answer is only in quadrants 3 or 4. That's a 60-degree reference angle, so that's over 3. So the answer then would be 4 pi over 3 is the only one where cosine's negative. All right, last one, 16. Again, it might be helpful just to do a little bit of algebra substitution to make it easier to work with. So I'm going to add 3. That's 12 and negative 7, so negative 4 and negative 3. So they have a 4x squared in common. That's x squared minus 1. Negative 3, that's x squared minus 1. Now x squared subtract 1 is x plus 1, x minus 1. And then we have 4x squared minus 3. So sine theta could equal 1. That would be at pi over 2. Sine theta alpha could equal negative 1. Oh, it's between the out. And so at negative 1, it's 3 pi over 2. When I get x by itself here, it's positive or negative the square root of 3 over 4. So that's root 3 over 2. And then that's a 60-degree reference angle. So it's over 3. And that would be, for a positive and negative, that would be 2 pi over 3 and 4 pi over 3. Now in the answer it says pi over 3, but that's not in the restriction. That's too small. So there's 4 answers. All right. Hey, you got to the end. I'm so proud of you. Mr. G Math, over and out.